Okay, so let's talk about this. So let's solve this different ways. So I know we've done a lot of different solving of quadratics. Let's just factor first. So factoring this, x and x got to be 5 and 1, both negative. So the solutions are x equals 1 and x equals 5. So on the x-axis, I know we have a solution at x equals 1 and x equals 5. Um, if you look at a couple different ways to look in this one. So right away you see that when it's in standard form, the y-intercept is going to be 5. So I know that one of the points is going to be there at 5. Um, let's go ahead and complete the square in this one. So move the constant over. So we have y minus 5, x squared minus 6x plus blank. And we're going to add half of 6 squared is 9. So add 9 to both sides. So I get y plus 4 equals x minus 3 squared, and then move that over so y equals x minus 3 squared minus 4. So I know a couple things. I know my vertex is at 3, negative 4. So 3, negative 4. So that's my vertex. See, that's vertex form. So 3, negative 4 is the vertex. So when it's in vertex form, we can easily get the vertex. Okay, let's look at one more here. So let's look at quadratic formula. So we have quadratic formula, which is x equals, and this would be opposite of b, which is 6 over 2a, which is 2 times 1, or 2, plus or minus b squared, which is 36, minus 4 times 5, 1 times 5, so 4 there. So this is going to be 3 plus or minus square root of, so that's really 16, square root of 16, which is 4 over 2, which is 3 plus or minus 4 over 2, which is 2, which is really two different answers. 3 plus 2 is 5, and 3 minus 2 is 1. So we get the same two answers that way as well. One of the things that you may not have, a connection you may not have made is this is the axis of symmetry. So it's always going to be in the middle of the graph. Because you could have gotten that from the h value of the vertex as well. But I want you to think about that in the terms of the quadratic formula. So the quadratic formula, just remind yourself, is x equals the opposite of b over 2a plus or minus, and then got all the rest of that. Square root of b squared minus 4ac all over 2a. But the part of that quadratic formula I want you to see is this part, this first part. This part of the quadratic formula, that when we hit 6 over 2 times 1, so the opposite of b over 2a is always the axis of symmetry. X equals h, or x equals 3 in this case, is the axis of symmetry. And that's really helpful to find that axis of symmetry very quickly just using a formula. So this is the formula we're going to use going forward. By the way, let's just go ahead and graph this. Looks roughly something like this. By the way, you also know there's going to be points symmetric with that point over there, so it's going to go through that point there, and there you go. Okay, so let's use that part of the quadratic formula. Is this the same problem? It is. So let's do a new one. Yeah, let's do it on this one. So I should make up one. Okay, how about x squared minus 8x plus 3? So one way of doing the quadratic formula is just finding, so it's going to be a two-step process. So step one, find h, right? H is the opposite of b over 2a. That's the formula I need you to know. So let's plug into this formula. So we'll get opposite of negative 8 is positive 8 over 2 times 1, which is 4. So right away, I know my axis of symmetry is 4. My vertex is somewhere on that line, right? So x equals 4. So that's my h value is 4. So that's just using a formula. Again, step one is plug into the formula. Step two, I'm going to say in words. to find k, plug in h. So in other words, we're going to do f of h is going to equal k. That's symbolically what's going to happen. That's a k, and that's h. Okay, so k, I'm going to take the equation, this guy, and everywhere there's an x, I'm going to plug in 4. 4 is our value for, so I'm plugging this value in right here. So I'm plugging a 4, and I'm plugging in a 4. And so k is going to equal 16 minus 32, which is negative 16, plus 3 is negative 13. So now we know the vertex is down here. Well, it's way down there. It's off the screen. But our vertex is at 4, comma, negative 13. Isn't that fast? Like that's a fast way to find the vertex. Hopefully I did that right. 16 minus 32 is negative 16, plus 3 is negative 13. That's right. I do know the y-intercept, right? The y-intercept is 3, so I know it crosses right here, which means it crosses if I go 4 units to the right over here, somewhere over here, it crosses as well. And so I could draw it if I could had enough graph paper to get all the way down to negative 15. Okay, so we're doing a little different version of this to complete the square here, but it starts out the same. So we're going to subtract 16. So y minus 16 equals 2x squared plus 12x. Because the coefficient there, because we have a leading coefficient of 2, that's going to change we're trying to put this into vertex form, but it's a little tougher when we have a leading coefficient. So I don't want to divide everything by 2. It gets too kind of crazy. So I think the step you need there is step 2, is you're going to, step 1 is move the constant. You're going to factor out the a value. Step 1 is move the constant. Step 3 is complete the square. So let's go y minus 16 equals 2 times x squared plus 6x. My next step is to complete the square, so I know I'm going to add something to both sides there. And then we have to figure out what that's going to be, right? So you do half that middle number squared, half of 6 squared is 9. Now be careful, I have to be fair to the other side. So this is where you have to be really careful. That 9 is being multiplied by 2. So I really added 18 to the right-hand side, so I'm going to add 18 to the left-hand side. So that's probably the trickiest step in this method. So we have y plus 2 equals 2 times x plus 3, quantity squared. And then last step, move the constant back over. So y equals 2 times x plus 3 squared minus 2. So we know our vertex, our hk, is going to be at negative 3, comma, negative 2. Negative 3, negative 2, that's our vertex. Our axis of symmetry is x equals negative 3. Everything should be symmetric with that. Our a value is 2. One way of graphing this, if this makes sense, is I know instead of going over 1, up 1, like I would normally do, I'm going to go over 1, up 2. Over 1, up 2. Instead of going over 2, up 4, which I would normally do, I'm going to go over 2, up 1, 2, 3, 4, 5, 6, 7, 8. Twice as many as normal because I'm multiplying those y values by 2. So over 2 to the left and 8 up. And you've got your parabola. This is one way of graphing it. Try to graph things as quickly as we can there. So let's do, is that the same problem? It is. So let's do this with the h equals opposite of b over 2/8 method. So this is just a two-step process. So it's not quite as elegant, but it actually kind of works about the same. So h equals opposite of b, so opposite of 12 over 2 times 2. Opposite of b over 2a is a formula. So it's negative 12 over 4, which is negative 3. I think that's the same value we got before. Step 2, we're going to plug that in. So k, not y, k is going to equal 2 times x squared plus 12 times x plus 16. And so we're going to plug in that value -3 in here, plug our h value into that problem. So we get k equals 2 times 9 is 18, minus 36 plus 16. So that's 18 minus 20, which is a -2. And that was the same point. -3, -2 is our vertex, right? That's our HK. It's our axis symmetry. Again, we could graph it just like we did a minute ago. One thing that is different, we know the y-intercept doing this form as well. I guess we could have plotted that way up there. It's a little bit off the grid there, but we know the y-intercept at least. But you can even write it from this. If you think about it, because our a value is the same, you could even write it in vertex forms. You could say 2 times x minus h, which is boom, boom, plus 3, plus k, which would be -2. So you can still write it in vertex form. We can still get the same result that we got this very elegant way of completing the square. You can actually get it this way using the h equals opposite of b over 2a method. So just a two-step method. Plug in h equals opposite of b over 2a, take that value, plug it in to the equation to get k. So really, if you have your a value, which is given in the problem in this case, a, h, and k, you can write your equation and then graph appropriately from there. So max and min values. So when a is bigger than 0, so if you have something like, y equal, like we just had, 2x squared, right? If a is bigger than 0, if it's positive, in other words, the graph is going to be shaped like this, right? It's going to be shaped up, which means this point is going to be a relative, or in this case, an absolute minimum. It's a minimum. I mean, in fact, if you have the hk value, the minimum value will always be k, whatever the k value is. So it's not actually, the minimum is the ordered pair, but the minimum value is going to be the k value there. That's what this says. The minimum value is there. And so this would be the minimum value of f if a is bigger than 0. In the second case, if a is less than 0, so if a is like, if you have something like y equals -3x squared, right? So a is negative. That means the graph is going to be opening downwards. So this point, this vertex, is going to be a maximum. And actually the maximum value, if this is h and k, the value, maximum value is going to be the k value there. So that's k right there. That's what it says. The maximum value is k. That's going to be a maximum when a is negative. And that makes sense. It's going to be opening down for the parabola. Find the max or min value. So that means find the k value. When you see the word value there, that definitely means we're finding the k value. So that means k, trying to find k. Well, the fastest way to do that, we just kind of did that, right? H and k, use the two-step method. So h equals the opposite of b, opposite of 1, over 2 times -1 in this case, which is +1/2. So h is +1/2. K, I'm just going to plug that in. Everywhere there's an x, this might take a little bit of work. I'm going to plug in a 1/2. So 1/2, 1/2. And so I get 1/2 squared. 1/2 times 1/2 is 1/4. So this is -1/4 plus 1/2 plus 2. And so let's get the same denominator. So we can add these up. So this will be 2 over 2. This would be 4 over 4 to get the same denominator. So I get -1/4 plus 2/4 plus 8/4, which is 10/4 minus 1/4 is 9/4. So 9/4 is the min or max. Is it a min or a max? Well, look at A. A is negative, so we know this graph is opening downwards, which means this is definitely a max. The max value is equal to 9/4. So you have to identify, is it a min or max? That comes from, is this positive or negative? And then what is the k value? What is that value that the highest the graph goes is 9/4? Find the local min or max in your calculator. Okay, so get your calculator out. So always go to the graph there at the bottom of the graphing apps. We're going to type in negative x to the power of, whoops, to the power of 3 plus 2x squared plus x plus 1. Or graph it. That's not too bad of a view. Sometimes we have to adjust our view. I think we're going to be okay with this one. So menu 5.1. Find the minimum. That's a relative minimum or a local minimum. I'm going to press enter to lay down the point there. There's the relative maximum. It's not the absolute maximum. The graph does go higher, but in that area, it's locally the and relatively the maximum there. So using those two values, we can definitely kind of write down the maximum and minimum. So if it asks for the min or max, like this is the maximum, the relative max, this is the relative min, is the ordered pair. So if it asked for min or max, that's your min and that's your max there, those ordered pairs. If it asked for the max value, it's 3.63 in that area, the local max value, if it asks for that one. But in this case, we're really looking for the ordered pair. So it depends. Are you asking for the value or are you asking for the ordered pair? If it just says min or max, it's asking for the ordered pair. Finally, in your book, vertex form, which is your book calls it standard form, but I'm going to say y equals, a times x minus h squared plus k. So the first few problems, once you put them into vertex form, maybe do complete the square for the first few problems in the first four. And then the rest of your homework, I want you to do the two-step method, the h equals opposite b over 2a, plug that in to get k, use that method for the rest of your problems. That's it. That's the end of the screencast.